So today we're going to be talking about the operations you use when you're working with decimals. So the first operations we want to look at are adding and subtracting. Anytime you're working with decimals and you're adding or subtracting, you want to make sure you line the decimals up within the problem and then solve it. So sometimes after you line up the decimal here, you're going to notice that there's a number that doesn't line up with another number. So if you want, you can fill in with a 0 and then you have a number for each of the digits. So if I go ahead and add these up, 0 plus 8 is 8, 7 plus 9 is 16, carry your 1, 1 plus 2 is 3, plus 4 is 7, 6 plus 3 is 9. And then for adding, and same thing with subtracting, is that once you're done, that decimal just comes right down. All right, and so your decimal is going to stay in the same place. All right, when you're subtracting, again, you want to start by lining up the decimal. Add a 0 if you need to. The larger number is on top when you're subtracting, so that's why that's there. It doesn't really matter with adding. All right, so then when we subtract, I can't subtract 7 from 0, so I'm going to borrow. That becomes 10 minus 7, which is 3. And I'm going to need to borrow again. And that becomes 13. 13 minus 6 is 7. And 4 minus 1 is 3. And again, I'm just going to drop down the decimal after I'm done. So 3.73. With multiplying, you're going to leave the moving of the decimal until the very end. So first you just solve the problem. It's like a regular multiplication problem. And at the end we're going to move the decimal, and we'll talk about that in a minute. Notice that when you multiply decimals, you don't need to line them up. And that's kind of really because you're ignoring the decimal to the very end. So we're just going to pretend it's not even there and just treat this as a regular multiplication. So I'm going to start with a 3. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6. 3 times 6 is 18. When I start the second row, I'm going to start with a 0. And then 2 times 7 is 14. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. 2 times 6 is 12. Okay, I'm going to add these up. 1, 5 plus 4 is 9. 6 plus 3 is 9. 8 plus 4 is 12. Carry your 1. 1 plus 1 is 2, plus 2 is 4, and then the 1. All right, so the last thing I'm going to do after I multiply is count the number of decimal places that I had in the problem, and that's how many, the total of that should be how many decimal places I have in my answer. So I can see right here, there's a 1 and a 7 that comes after the decimal, so I would count that as 2 decimal places. And here, there's a 3 after the decimal, so that would count as 1 decimal place. So together, that's 3. So that means in my answer, I need to have 3 decimal places. So I'm going to start from the back and move the decimal 3 places. So 1, 2, 3. That puts the decimal between the 2 and the 9, so my final answer is 142.991. Okay? All right, when you're dividing, this one, when we teach dividing, normally we talk about the fox and the rabbit. Okay, so we don't really want to divide by a decimal, so what we do is we move the decimal. So you're going to look at a problem. Here this problem is set up, and you're going to look at the decimal that's on the outside of this division house right here. If the decimal is only on the inside and not on the outside, then you don't have to worry about it. It's only when you're dividing by a decimal that you have to move anything. So we call this the fox, and we call the decimal inside the rabbit. And what's going to happen if a fox starts to chase the rabbit? Okay, it's going to move away from it. So we move the decimal over until we hit this little wall here. So this time we're going to move the decimal 1 place. That means the rabbit is also going to move over 1 place. All right, and then now this is no longer 1.3, it is the number 13, right? So this wasn't written in the notes, but I want you to go ahead and add it. I think between steps 2 and 3, why don't you go ahead and rewrite the problem. It's just not as messy, it's easier to read. You don't lose your decimal, right? So instead of 1.3, I'm going to rewrite this as 13, and now I'm dividing into 893, and the decimal's right here, 0.1. Okay, so then I'm going to treat this as a regular division problem. I can't divide 13 into 8. You can put an X or a 0 there. 13 will go into 89. I'm going to say 6 times. 6 times 3 is 1878. Okay, so when I subtract, I get 11, and then I'm going to bring down the 3. 13 will go into 113. 8 times times 3 is 24, 104. Okay, so when I subtract, I get 9, and then the decimal goes up, it jumps up. Remember, it's a rabbit, so the fox chases a rabbit, and the rabbit can jump up above the wall. And then you can bring down the 1. So 13 will go into 91 7 times. And then I'm going to stop because I have nothing left over, right? So my answer for this one is 68.7. Okay, now as you divide, sometimes you may have a remainder here, and so you would add a 0 and keep going. And we're going to ask that you always go at least 3 decimal places, but then you can stop. So if you have a decimal that's just continuing on forever and ever, just go 3 places and then you can quit. Okay, all right. Now, what may be new about decimals this year is that we're going to combine what we know about integers with what we know about decimals. So the same rules you use for integers also apply for decimals. So this is negative 2.1 plus a negative 3.15. All right, so the integer rule says when I add and they have the same sign, okay, that I add them together and keep the sign the same. So that's what I'm going to do. I'm going to add these two numbers together. I'm going to do these in order because that's order of operations. So I have to line up my decimal, because that's how I add decimals, 3.15, and I'm going to be adding, right? I'm going to fill in with the 0 here and add. So that gives me 5.25. I drop the decimal down. Because I'm adding two negatives, my answer is still negative. So this is negative 5.25, but then I still have the plus 4.2. Okay. So now, if I have a negative and a positive and I'm adding, those are different signs, so I actually subtract the numbers. So now I'm going to take 5.25 and subtract 4.2. And again, I'm lining up my decimal. Okay, so I'm going to add a 0 here in order to keep everything lined up, and I'm actually subtracting because the signs are different, not because of the adding, but because this one's negative and this one's positive. So this is 5, this is 0, 5 minus 4 is 1. I'm going to drop my decimal down. So I get 1.05. Now just be careful with the signs. So when I subtract with integers, I keep the sign of the one I have the most of. So what's going to be, what do I have more of? The negatives or the positive? Well, even if you don't look at the decimals, right, you just look at their whole numbers. Negative 5, there's 5 negatives, there's 4 positives. Okay, there are more negatives than positive. So my answer is negative 1.05. Okay? Here I have 8 minus 10.36. So when I subtract integers, I want to start by rewriting those as addition problems first. So I'm going to rewrite 8. I keep the 8. I change subtraction to addition. And I change the sign of the second number. This is keep, change, change. Right? So 10.36 becomes negative 10.36. Right? So now I have a positive and a negative number that I'm adding. The signs are different, so I actually subtract them. Now, when I subtract, I'm going to start with the larger of the two numbers. So I'm kind of ignoring the negative positive until I'm done subtracting, but 10 is going to go on top because it's bigger. There are more negatives than positives. So 8 is going to go down here. Now, 8 doesn't have a decimal, but just like you put a period at the end of the sentence, when you have a number without a decimal, it is always at the end of the number. Okay, and then I can add zeros here and subtract. All right, so that gives me 6 and 3, and then I would have to borrow. That gives me 2. I'm going to drop down my decimal. So I have 2.36, but I want to check my signs and make sure I do this correctly. So when I subtract, I want to keep the sign of what I have the most of. So I have 8 positives and I have 10 negatives. So there are more negatives than positives, so my answer is negative 2.36. All right, multiplying. Again, I'm going to just start by doing the first two numbers. Okay, so 3.2 times negative 0.45. I can know right away, since I'm doing a positive times a negative, if you're not sure, a positive times a negative, okay, then my answer is going to be negative. So when I multiply these two numbers, I know I'm going to get a negative number, but I can multiply them just normally. All right, so 3.2 times 0.45. I don't need the 0, that's just a placeholder. And notice I didn't line up my decimal because I don't have to when I'm multiplying. 5 times 2 is 10. 5 times 3 is 15. Plus 1 is 16. Start with the 0. 4 times 2 is 8. 3 times 4 is 12. Add these up. It's 4 and that's 1. Okay? And then with decimals, I need to make sure I count where I want my decimal to end up. So there's one decimal here, 1 decimal here. There's 1, 2 here, so that's 3 total. Move it over 3 places. It gives me a decimal between the 1 and the 4. And I can keep the 0, but really I don't need it. So I'm just going to rewrite this as negative 1.44. But I still have to multiply times negative 1.03. All right, so a negative times a negative, those are the same signs, a negative times a negative. So I can see that my answer is going to be positive, but I'm going to multiply like normal. All right, so 1.03 and 1.44. 3 times 4 is 12. Carry your 1. 3 times 4 is 12 plus 1 is 13. 3 times 1 is 3 plus 1 is 4. Start with a 0, and then I'm going to do 0. 0 times 4, 0 times 4, 0 times 1. When I start my third row, you have to start with 2 zeros, and then 1 times 4 is 4, 1 times 4 is 4, 1 times 1 is 1. Okay, add these up. I get 2, 3, 8, 4, and 1, and then I'm going to figure out where my decimal goes. There are 1, 2 decimal places here, 1, 2 here. That's a total of 4. 1, 2, 3, 4. Puts the decimal between the 1 and the 4, so this is 1.4832. And since a negative times a negative is positive, this is a positive 1.4832. Okay? All right, division. When the problem is written like this and you're trying to figure out, well, how do I set this up as a division problem? You can remember the first number, this first number goes inside your division house, right? So the 0.672 goes inside the house. The second number, or the last number, goes outside the house, 1.2. Okay, now I'm not going to worry about the negative till the end, but I can go ahead and figure out if my answer is negative or positive. These have different signs, a negative and a positive, a negative and a positive, so my answer is going to be negative. In fact, I'm going to write that down so I don't forget it. But then I'm going to divide like normal. Now, I don't want to divide by a decimal. I'm going to move that, so I'm going to remember the fox and the rabbit. So if the fox moves once, the rabbit moves once. And now I have a new problem. I'm going to divide 12 into 6.72. Okay, 12 doesn't go into 6. I'm going to bring up the decimal. Now 12 will go into 67 5 times. That's 60. When I subtract, I get 7. Bring down the 2. 12 will go into 72 6 times. Okay, and then I can stop. So my answer is, remember I have the negative from a negative positive, so this becomes negative 0.56. If you want to put the 0 in front, you can. It's up to you. You can write it either way. Just don't forget the negative. Another way you could possibly write division as a fraction. We call this top in, bottom out when we see it like this. And so that's, again, just another way to remember how to set up your problem. The top number goes inside the house. The bottom number goes outside the house. All right, and then it's just a regular division problem. All right, so this, again, I have a fox and I have a rabbit. So all my foxes are moving one time, but you can move this as many times as you need to until you get to the wall. So I'm going to move it once here, which means I'm going to move it once here, and I'm going to rewrite it. So now I'm dividing 4 into 12.31. So 4 won't go into 1, it'll go into 12 3 times. When I subtract, I get 0. I'm going to bring up my decimal and bring down my 3. All right, 4 won't go into 3, so I need to put a 0 here to show that it did not go into the 3. 0 times 4 is 0. That gives me 3, and I'm going to bring down the 1. All right, so 4 going to 31, 7 times. 4 times 7 is 28. When I subtract, I'm going to get 3. Okay, so since I have a remainder, I'm going to keep on going, which means I'm going to add a 0 here so that I can bring it down. All right, so the 4 will go into the 30, 7 times. 7 times 4 is 28. When I subtract, I'm going to get 2. All right, and then I could bring a 0 down and keep going. All right, and actually if I do, it's going to stop. So I could do 4 into 20 and get 5. All right, and that's the answer. It would stop here. Okay, but if I have a number that keeps going, as long as you have 3 decimal places, that's correct as well. All right, so last thing I want to do is check my sign on this. I have 3.0775 or 3.077 if you stopped when you got to the 3rd decimal place. And then a negative divided by a negative is positive. So this is a positive 3.0775. All right, so again, there's several ways to write division. You can write it like normal long division. We can use the division symbol, or we can write it as a fraction. And I didn't point this out with multiplication, but it's true as well. You have the x. We don't use that very often anymore, but you will see it occasionally. You can use parentheses to mean division, to mean multiplication. And then there's also the dot that we'll see later on too. Okay, thanks. Have a great day.